All right, the fun continues with section 2 of chapter 12 or 16. We're going to talk about cutting energy waste a little bit now. So, in the United States, industry accounts for about 38% of the energy consumed. And so how can we save that money a little bit? Well, first of all, remember there was a lot of energy waste when it came to making electricity. So if we can create systems like the natural gas system I showed you when we talked about natural gas in chapter 15 that are cogeneration, meaning they do two things at once. We use the heat as well as the electricity produced from one energy source. We multitask that energy. We have the potential to utilize a higher percentage of the energy and make things better that way. We can use electric motors that are more efficient. We can recycle materials. Just switching from incandescent bulbs to fluorescent bulbs, or even better, LED lighting, can save lots of energy costs. We can change and update the electrical grid. That's the stuff that brings the power lines and stuff that bring the juice to your house. Old stuff has a tendency to bleed more energy and power and waste more. And so if we change that out, we could be more efficient. And then utility companies like power companies basically promote you to use more electricity. They want you to use more. And the more you use, the more they make. If we switch that to promoting conservation, you use very little energy, and that is a benefit to the electrical company in some way. If we change that philosophy, we could increase and save money as well. Now, how do we save money in transportation? Well, remember 2/3 of our oil usage in the United States goes to transportation, and it accounts for lots of air pollution and all kinds of problems. So if we can reduce that and save that energy cost in certain ways by maybe creating more fuel efficiency and making cars lighter and stronger from that perspective, we can reduce the amount of wasted energy there. And we've already seen that start to change. For instance, Ford is now producing a truck with an aluminum frame as opposed to a steel frame. It's both stronger and lighter and helps with the fuel efficiency of that vehicle. When we talk about fuel efficiency standards, the corporate average fuel economy, the CAF standards, dictate how many miles per gallon vehicles need to have. And currently those are pretty low numbers, and we could increase those, and that would help out significantly as well. So making more fuel efficient cars to place in the market, and then giving tax breaks to people for buying fuel efficient cars. All of these things could benefit that bottom line. So when we look at those fuel efficiency standards, they did not increase. We didn't expect better gas mileage from 85 all the way to 2009. And so as a result, if you look at this graph up here, the United States is this line down here. That's the expectation we have for fuel efficiency of cars. It's below 25 miles per gallon. You see that Canada, China, Japan, and all of Europe have much higher standards for fuel efficiency of cars. And if they don't get to that, they're not certified to be on the road. And so in 2009, Obama actually increased those standards to 35 miles per gallon for all domestic transportation vehicles by 2016. And in 2012, he upped it even higher to 54.5 by 2025. And working towards those standards will reduce fuel costs dramatically. I mean, really, you're going to cut, if you go to 35.5 from where we are now, or where we were in 2008, you'll cut 33% of fuel consumption, of domestic fuel consumption, which is a huge amount of energy savings. And so how do you do that? Well, one possibility is hybrid cars. Hybrid cars basically have used two engines or just an electrical engine, and they can increase fuel economy, gas mileage, between 50 and 70%. And you're going to get it for less emissions. So standard power engine is in there, and electric engine is in there typically, with a series of batteries. And this comes in variations. There's the gas-electric hybrid, which most people drive if you drive one, like a Prius is that. You put gas into it, which makes electricity work. The other one is that same exact system, but you plug it in at night at your house. And when you, like this picture over here, you plug it in at night at your house and you charge up the batteries. And so you don't start using gas until you run out of that electrical power. And then there's also 100% all electrical cars out there as well. And so all three of those are potential options for this. And so these are your conventional hybrid and your plug-in hybrid. So a conventional hybrid has a fuel tank and a battery pack. And you basically burn fuel in your combustion engine, which then creates electricity to run your electrical motors. So this is your regular Prius. The plug-in models, which we're starting to see a little bit, but they're not very common yet, again, have a fuel tank, but a much bigger battery tank. You see the difference in size between the two, so they can hold a much more of a charge. And they work on the same premise. The only difference is when you plug it in at night, the ones right now, you can get about 40 plus miles on the plug-in that you did in the morning before it starts using any electricity. So those people who are driving to and from school and they live in town would really not use very much gas at all in their regular life. Maybe only when they took trips to Casper or whatever would they start using gasoline, which would save a lot of that, and we'd be using other energy sources like plugging in at your house. You're using some hydroelectric from up at Kayak, for instance. Hybrid cars are not very common, though. Only about 3.5% were on the road in 2012. And that increased a little bit by 1% from earlier. So they're a growing section of the world, but they're still not high yet. Part of that is their expense. On average, they're going to cost you $3,000 to $4,000 more than getting a regular car. The plug-in hybrids can get you way better gas mileage than just a conventional electric hybrid. But how are you generating electricity? If you're still generating it with coal or nuclear power, it can be just as bad, environmentally speaking. But if it comes from wind or solar energy, or hydro energy even, that's a much better approach from an environmental perspective. And then in order to get it to consumers in a meaningful way, we need to boost sales. So we need to expand that. And how do you do that? Do you do that with government regulations? Do you do that with incentive programs? There's lots of ways to increase people's likelihood of owning one of these. Excuse me. So what are some current obstacles to the hybrid cars? First of all, storage capacity of the batteries. Most of them don't have much of a range, at the most 100 miles, and that really limits us, especially here in Wyoming. Now, is it applicable in Wyoming in some cases? Yes, but there are limitations to it. Charging time. Like the Nissan Leaf is an example of it, and it takes 8 hours to get it fully charged, which means if you plugged in all night long, that's one thing, but not in all cases. Now, the Ford Focus EV, electric vehicle is what that stands for, can be charged in 3 hours. This is helping out. So the faster we can get them to be charged, the better. You can drive it to work, plug it in at work, have it charged when you're ready to leave work. So having these options and capacity changes could be really beneficial to it, but it's a process that we're going through here. Okay? And the other major problem is the batteries themselves. The construction of the batteries actually have some environmental hazards to them. They use a lot of earth metals to do it, and so we need to be careful about that. I read a thing where they talked about making Priuses, and in the end, it was worse than regular cars to build because the batteries, for instance, you mine the metals for the batteries in one place. Then you shipped them halfway around the world to build the batteries. Then you shipped them back to the other part of the world to put into the cars. And then you shipped them back from being made in Japan over to the United States for sale. And so in the end, the amount of fossil fuels and stuff burned to do that was just an astronomically high number. And so without thinking about some of those concerns, we have issues moving forward. So the next idea we have is green architecture, other ways to save money besides with just vehicles. Green architecture is looking at ways to build buildings that are more energy efficient. So instead of using more heating and cooling, we can use passive heating in our homes. Design the houses in a way that the sun can come in, provide natural lighting, provide heating by the sun absorbing into the natural materials, having venting systems designed in your house to naturally vent your house and cool it. Like in tropical areas, a lot of times they use sea breezes to work their way through. Collecting rainwater, creating heating and electricity systems that work together, using geothermal pumps and recycled materials. All of these can help save energy costs when it comes to building. In addition, living green roofs. These are down here. So the roof of your house, instead of just being a flat, hard surface where water runs off of it, make it something that grows and absorbs. The green roof can be used as an herb garden. It absorbs excess water that doesn't need to run off things. It keeps your house cooler. There's lots of benefits to it. Super insulation, so we don't waste as much on energy bills. And a company that kind of manages this, the U.S. Green Building Council Leadership in Energy and Environmental Design called LEED, does certifications for people on how good of an energy, green, architecturally built system you have. And there's a variety of certifications. You can be certified. You earn points for doing certain things. Having energy efficient appliances, having a heating and cooling system that's efficient, type of roofing you have, type of insulation you have. You get points. So it's graded on a 100-point scale. And so if you're in the 40 to 49 range, you can be certified. Silver, even better. Gold, and then platinum means you are extremely energy efficient building, top notch. So how do we do it in existing buildings, not just building new ones? Well, we can insulate and plug leaks, which, if you look at this picture down here, shows all the heat loss out of an old conventional building. Crazy large amounts through the windows, through the doors, cracks, holes, all that kind of stuff. So sure that up. Replace the windows with more energy efficient windows. The heat loss we just talked about. Heat your house more efficiently. There's lots of efficient heating systems that allow your house to heat and cool much more efficiently than we do now. Heating systems for water are the same way. I, for instance, have a tankless hot water heater at my house. So that's more energy efficient than a conventional one. A conventional one heats up water and then keeps it hot, even when you're not using it. Instant hot water heaters don't do that. So make shifts in those kind of things. Switch the appliances you use. If you're using a 1970s dryer, the amount of energy it's using versus a brand new dryer, vastly different. And then use a lighting that's more energy efficient, like the bulbs we talked about earlier. So this is a breakdown of some of those things within your house and what can be done in different places in your house. This is also in your book, so that's a good thing to peruse through in your spare time. So, why are we still wasting so much energy then? Well, there's a couple reasons. All of those things, but at the end of the day, we currently have pretty low fossil fuel prices. And as long as they stay low and people can do this for cheaper, that's what people will do. And there's not very many tax breaks and financial incentives to make the switch to better energy efficiency. So if we made those shifts from a governmental point of view, it could force people into working more from a energy efficient point of view. So there's lots of energy that are renewable that will solve several of the situations, and we've talked about all of these. And so that's what your packet's for, and you need to be aware of each one of those. Right, that's it for this chapter. Peace, love, bye.